Okay. So today we're going to look at adding, subtracting, multiplying, and dividing functions to perform arithmetic operations on functions, and we're also going to compose some functions. Now, adding, subtracting, multiplying, dividing, not tough. You can add, you can subtract, you can multiply, you can divide. That might be the harder of them all. But we're also going to learn how to compose functions, which you should remember from Algebra 2, but you may or may not. So we're going to go over it just like you may not have seen it before. So there's that to keep in mind. So the first thing we're going to do is looking at the algebra of functions. The algebra of functions are very simple. It's just algebra with functions. So if we see f plus g, that means we add the y values of f to the y values of g. If we see f times g, we add the y values for f times the y values of g. If we see f minus g, we do the y values of f minus the y values of g. And if we see f divided by g, we take the y values of f, divide by the y values of g, provided that g doesn't equal 0, because we can't divide by 0. Okay, so the first thing we have here is we're asked to find each function given the initial pair of functions. So f of x is 3x squared plus 2x plus 1. G of x is 5x minus 2. They want us to add these together. So we're going to add f of x, which is 3x squared plus 2x plus 1. And we're going to add g of x, which is 5x minus 2. We're adding. So we just combine like terms, and we get 3x squared plus 7x minus 1. The next one says to subtract. We're going to do g minus f. So we're going to take 5x minus 2, and we're going to subtract 3x squared plus 2x minus 1, or sorry, plus 1. So when you do that, you're going to distribute that negative sign through. So when you distribute the negative sign and then combine like terms, you're going to have 3x squared, and it's going to be negative. So negative 3x squared. A positive 5 and a negative 2 is a positive 3x. And then we're going to have a negative 2 and a negative 1, which is a negative 3. Then the last question says f minus g of 4. So we could do this a couple of ways. The first way is to figure out what f of 4 is. So I plug in 4. So 3 times 4 squared plus 2 times 4 plus 1 is 57. Then I find g of 4. 5 times 4 minus 2 is 18. And I want to do f minus g. So I'm going to do 57 minus 18, which is 39. Now the other way you could have done it is you could have done f minus g just like we did here, but had 3x squared plus 2x plus 1 minus the quantity 5x minus 2. Simplified that answer and plugged in a 4. It's really a matter of choice, whichever way you want to do it. Okay, so using the last examples, try these on your own. So pause the video and then come back to check your work. I said pause the video. Okay, good job. Now, composition of functions. It says that the composition of function is a function evaluated at another function. So for instance, the composition is defined as f of g of x, f circle g of x, or f of g of x. These statements are read f composed with g of x or f evaluated at g of x. Lots of times you'll see it written like this, FOG, or sometimes you'll see GOF, G-O-F. What that is actually telling you to do is to take the g function and plug it in to the f function, just like it is here. Okay, so what we're going to do is we're going to compose these two. So we're going to do f following g of x, and then we're going to do g following f of x. So the first one says we take the g function and we're going to plug the g function into the f function. So we're going to take this g and plug it into f. So we'll have 3 parentheses 5x minus 7 plus 2. So that's going to be 15x minus 21 plus 2. So it's going to be 15x minus 19. So that's f following g of x. Now what it's asking us to do is the reverse. It's asking us to do the opposite direction. So what we're going to do is we're going to take, and now we're going to put the g function, and we're going to take the f function and put it into g. So we're going to take this 3x plus 2 and plug it in for x. So we're going to have g of 3x plus 2, which means 5 times 3x plus 2 minus 7. So that's going to give us 15x plus 3. Are these two the same? No, they're not the same. Nothing special happening here. If you do this and they're the same, that's something special. If actually you do this and they both equal x, they're called inverse functions, but that's a story for a later day. Okay, now we're going to do the same thing. We're going to simplify our answer. We're going to do f of g of x and then g of f of x. So again, we're going to start with placing the g function into f. So we're going to have x squared. We're going to place x squared with 2x squared plus 1. So 2x squared plus 1, quantity squared, minus 4. Now, ladies and gentlemen, be careful here. This says 2x squared plus 1, quantity squared. So we've got to take 2x squared plus 1 times 2x squared plus 1. Combine like terms. And we're done. Then we're going to take g of f of x. So we're going to put x squared minus 4 in for x. So we have 2 times x squared minus 4 all squared plus 1. So we do our squaring first. So we're going to take x squared minus 4 times itself, then take that times 2, then add our 1. Are they equal? No, not even close. So here's the question then. Since they're not equal, does the order of the composition matter? So if we look back, these weren't equal. We did f first, or we did f of g, and then we did g of f. And we go backwards. These weren't equal. We did f of g, then g of f. They were still the same functions, but in a different order. So does the order matter? Yeah. The order matters. Inverse functions. An inverse function to f is a function that interchanges all ordered pairs. The inverse function is denoted by f to the inverse, or f to the negative 1. A function has an inverse function if that function is 1 to 1. This means each x value corresponds to only one y, and each y value corresponds to only one x. So to be a function, it passes the vertical line test. To be a 1-to-1 function, it has to pass the vertical and the horizontal line test. So to be an inverse, it has to be 1-to-1, and to be 1-to-1, it has to pass the vertical line test and the horizontal line test. This means that if two functions are inverses of one another, the x values and the y values are interchanged. So the inverse of the function and the function, if the ordered pairs were 1, 2, 2, 3, 3, 4, the inverse function would be 2, 1, 3, 2, 4, 3. The function is 1-to-1 if it passes the horizontal line test. It means that a horizontal line will pass through the function no more than one point at a time. So to verify that two functions are inverses, you compose them. When you're looking at the graphs, they're reflections over the line y equals x. So let's take a look at these. First thing we're going to do is we're going to graph these. Use a graphing calculator to show the functions are inverses. Graph them both on the given axis. Well, the first question says f of x equals x plus 5. So our y-intercept is 5. We go up 1, right 1, up 1, right 1. The second equation says x minus 5, so our y-intercept is negative 5. Our slope's the same, up 1, right 1. So verify that these functions are inverses. Well, if I reflect over that line y equals x, if I folded these, they would be directly on top of one another. So how do I show that algebraically? Well, to show it algebraically, I need to do f of g of x, which is x minus 5 plus 5, which is just x. And then I need to do g of f of x, which is x plus 5 minus 5, which is x. Since they both equal the same thing, they both equal x, that tells us it's a function. So if we graph 2x minus 7, we have a y-intercept of negative 7 and a slope of 2. Second equation, we have a y-intercept of 3/2 and a slope of 1/2. If we look at the line y equals x, they do in fact reflect over each other. So now we show it algebraically. We're going to put g of f of x, and then we're going to do the other one. Given a one-to-one function, find the inverse. Well, how do we find an inverse? Well, we just said in our definitions that when we write the inverse, the x and y switch. So what happens is we're going to replace f of x with y. Then we're going to switch the x and the y. And then we're going to solve for y. And then replace y with f inverse. So now we know that x minus 7 and x plus 7 are inverse functions. Likewise here. Replace g of x with y. Replace x and y. Solve for y. And then replace y with g inverse. So those are inverse functions. So if I composed them, 12x divided by 12 is x. 12 times x over 12 is x. Replace h of x with y. Switch the x and the y. Solve for y. So we would multiply by 4, subtract 5, and divide by 3. Then replace our y with h inverse. I'm not going to talk, I'm just going to let this one come up. You can try it on your own. All right, and that's how we would solve those. Thanks for coming out.